doing? Ooh, you've just eaten. So, you know, it would be good to have a very funny presentation so that you don't sleep. But unfortunately, this is more useful than funny. Sorry for that. But I will try to do my best. It's nice to see all you here. If you have colleagues that are wondering what they want to see, this is something that you can use even tomorrow, even on production. So, yeah. First about me. My name is Ratajski. That's my Twitter, so please tweet. What do you think about the presentation? That's my email. If you have after the talk some questions, email me. I am developer, wizard, and an architect. I use this title because it mostly shows what I'm doing. I live in Lucerne, very nice city in Switzerland. You see how beautiful it is? And yeah, I work for CSS Insurance, CSS Versicherung. So this is probably the biggest company in health insurance in Switzerland. Unfortunately, we still don't insure your style sheets. But if we start, sure, it will be awesome. We are working on that. Okay, and that's my Pokemon, the technologies I used before. Almost all of them I hate, but okay. So what is gonna be about this talk? So first, I will show you a small demo. Will be a code. Code speaks best. Then I will show you, tell a little bit what is a non-blocking architecture. Then the real demo, because the first one is a stupid demo. And then I will describe the technology stack that I propose for you to just think about it. And generally the talk is about something called Ratpack, but it's not only Ratpack that I'm going to discuss today, also some alternatives at the end. And by the way, I don't try to rewrite or describe your manual. This is experience. After the talk, if you want to use Ratpack, you would have to go to the page. There is a page that you can start, and this time, almost spring. No, this one, Ratpack.io. Everything you want to know is there. Okay, go back to the talk. I am, in fact, Java EE developer for 17 years. I started with first JBoss. Can you imagine that? JBoss 1. It had a little bit different name. So probably we even forgot what the JBoss is. But really, I was, like in the year 2000, I was so keen on doing enterprise Java beans and things like that. And then through years, I learned all of that technologies. I even was doing some workshops, etc. But then, like 2 years ago, I was discussing with people, and I was believing in this technology. That's also important. But maybe it was like 2 years ago, I was discussing with people, and slowly was converted, let's try Scala. And after I went to Scala, I spent there a little time, and this is how I see right now all my technologies from Java from the past. Like Spring, Hibernate. It's typical what the Scala developer thinks about it. And my goal is that at the end of this talk, you will have similar view, even though, who is the Java developer? Oh, most of you. So I will try to show you why I feel like this poor man on the picture. Okay. So the demo I'm going to present now is the second, it's important, second most useless Fibonacci implementation. And the code is on a GitHub, you can check. But let's go to the code. So it's like, this is the server I want to describe for you. Sorry for just a moment. There will be no live coding. I don't have enough time for that. But I will show you the code because it's not that much. So I learned in the meantime that every good story starts from public static void main. If you don't have this method in your code, you're already doing something wrong, probably, mostly. So my story starts with public static void main. And then I'm using this method create server because I delegated. We can use it later if we have time. But basically, this is how you can create web server in Java. So who was using servlets, Tomcat, JBoss, whatever in the past? Spring Boot. So basically everybody. Who has used something else, like not on servlet technology? On a couple of hands. So this is this else. Else means we are writing really in public static void main, and we are doing web server without any magic. You will see. So Ratpack, there is a library. That is library or a tool that you can easily import. I won't show you Maven or Gradle. It's not important. It's easy to find. Then you have really simple method, Ratpack server start. And what do you do in this method? You describe what is the server doing. How you describe? By lambdas. We have lambdas. We can describe with lambdas. And for instance, we configure a server. We say that the server is in development mode. It means it shows errors verbosely. I say that I will be using 200 threads, which is stupid, but you will later see why. But for a moment, let's do it with this 200 threads. And I am opening this server on port 5050, which is by the generally default port for Ratpack, just not to confuse it with Tomcat 8080, but it's OK. And then some connection timeouts. All of settings you can do this way. So first interesting thing, you configure the server by lambdas, which is great. I will show you later why. But then in every server, maybe you won't like to have some endpoints. Like if somebody makes a request under the prefix, you see the prefix here. And the prefix is Fibbo because it's going to be Fibonacci implementation. Then what I am doing, I am saying that under this prefix, maybe if someone is using get method, HTTP get, how simple, then I will, with parameter n in a path, so like this, then I will do that. So first thing I'm going to do, I'm right now in this implementation. So what I'm going to do, I'm going to interpret this n. So right here. Maybe, to show you that it's working, for a moment I will write here, hello GeeCON, OK? And we will start, just a moment. Server is there. So, and if I go here, this is this server, and there should be n less than 2, hello GeeCON works. First interesting thing is that it works fast. So hello GeeCON, and it restarts fast. And it's not even the fastest that you can see, because you can do it even faster. But you see, it's there. No length deployments, whatever, just there. Simple story, public static void main. And I'm there. OK, I will go back to this implementation, because normally in Fibonacci, if it's less than n, then we just print n. It's not perfect, but it's good enough. And then why this implementation is stupid? Because you know of recursive Fibonacci. It's not very efficient to do recursive Fibonacci, but it will typically give you a job in any company. If you can do that, you will typically pass the test. But not if you do it this way, probably. Because right now, I'm doing recursive Fibonacci, but using HTTP. So I have a server, for instance, I'm asking with Fibonacci of 5, and then I will do recursive call with HTTP client to the same server. How cool. Who thinks it will be fast solution? Great, it won't. So, and then interesting thing, I could use normal HTTP client and wait for the response, and you will see later this solution, but I am doing this asynchronously. It means there is this HTTP client. It's built in Ratpack, but there are other libraries that do the same, where I can ask for, like you see, Fibonacci from n, but I don't return a long. I return promise of long. Which one of you have already seen something like promise, future, completable future? OK, a lot of you. So for those that don't know, it's not the long, it's a promise that the long will be there. and it's like basically like container, like list of long, or maybe optional of long, but it's optional in the future. So we do a request with n-1 and n-2, and then once we have both of them, we should add them. And here is this interesting thing, flat map. Who of you knows flat map? Flat map, okay. So basically flat map is an operation that here allows you to having two things in the future, combine them into one thing in the future. So if I have both of them, then in this moment, I can add both values and have this one in the future from 2. So if the n2 comes first or n1 comes first, doesn't matter. I just somehow wait. In fact, I don't wait here, but I give a callback that once both of them are available and solved, then I have this result long, and what I do then with a map operation and convert it to string, because at the end of I render this string. So how much is a Fibonacci of something? An interesting thing here, I don't render a string. I render a promise of string. And that's basically how Ratpack works. Let's see it in a browser. So I'm not sure if I restarted Ratpack, so I'll restart. Just doesn't take much time, so let's do it. And right now I'm Fibonacci of 1, Fibonacci of 5, Fibonacci of, okay, something more interesting. Takes some time, Fibonacci of 15. Takes some time, it's not very efficient. And Fibonacci of 20. Okay. Does it? Just give it a time. It did it. So you see it's not performance solution. But let's now skip to something, because it does so many recursive calls. Let's skip to other solutions. So 1 hour ago here was presented a Spring, the new things in a Spring. But I'm going to use the old things of Spring with servlets that you typically do with a servlet. So basically, it means this is blocking architecture. So this is the same Fibonacci. I even use here on a purpose something like completion states, so futures, but I'm not really fully asynchronous, because here I call operation get. It means I don't render promise of string. I wait till I have this value and then render it, because in the classic approach with a web servers in Java, that's all you can do. You have to wait, and you have to block the thread that is processing the request. So we will see how it works this time. Started, you see the best thing in Spring is this ASCII arc. So how cool, it started quite fast, in fact. And right now, this is the Spring version of 6, works perfectly. Of 8, works. Of 10, works. And just a moment, so maybe 13. You know, in this Ratpack version, 20 was a lengthy operation. How much time you think will 13 here do? So answer is never. So sometimes it happens, but it's really, you have to be very lucky. What happens? Who of you knows? Can you? Exactly. So if you had, I will show you later on the screen something that happens here. Basically what we get here is a deadlock. It will never answer, or it will be incredibly slow. This is the, by the way, there is possibility even in the old Spring to resolve that, because there are possibilities of doing asynchronous responses right now. But it's basically, I say, we'll show this asynchronous solutions with Ratpack, not with Spring. So you see some errors here, so it didn't really work. So the next thing, but we'll discuss this, what happened later. Just remember this moment. Next thing that you may wonder is those threads. So just let me stop this thing. Let me stop, oh, you've seen here an error. Let me discuss this problem. 200 threads, what does it mean? So maybe I will I have to skip the presentation mode because right now it slows me down. Exit presentation mode and exit. OK, it's OK. I will do some very bad benchmark. Bad benchmark means it's on a virtual machine. It's not a very good conditions for benchmark, but let's do that. And for very bad benchmark, there's a tool called Apache benchmark, AB. It's just, don't worry about it. It's a very stupid tool. Means that I will be doing 2,000 requests. So I will do a load with 50 concurrent, doing Fibonacci of 10. And let's see what the result is. We'll be looking at this 95 percentile. So just give it a couple of seconds. Give it time. Ta-dum, ta-dum, ta-dum. Just a moment. And we'll get some kind of number like this. Maybe, once again, sorry, but if we want to get the good numbers, we have to repeat it and see that they are more or less the same. Otherwise, maybe we are measuring some garbage. But by the way, this is a very unprofessional benchmark, but I don't have time and right now to do it very well. Just, I want to show you only something. So 50 concurrent queries for a get of Fibonacci of 10, and together we do 2,000 of such, and we get result like the 95 percentile is like 500 milliseconds. Okay, but we have here 200 threads. What will happen if my whole server will be using one thread? Who knows? Who thinks it will give better result? Who thinks it will be way worse? Okay, so only a few of you were brave enough to make a bet. So first run, it doesn't matter, just ignore the results. I have to warm up JVM. You know of that. Just don't look at it. Dum-da-dum-da-dum. Works. So first thing you see, the server really is using one thread. And 50 concurrent requests at a time still are served. The results are bad at the moment, but it was like not really warmed up JVM. So once again, so the solution, the result of 200 threads was 500 milliseconds. This is, once again, this is more garbage than the real benchmark, but you see something that's repeatable. It's a little bit better with one thread. Who thinks it's strange? Raise your hands. Who thinks it's strange? Yeah, I get better performance with one thread than with 200. Who of you heard about Node.js? Who has heard that Node.js is performant? Yeah? And the thing, you know that Node.js is single-threaded, basically? Yeah, it is, and it works. So the same thing we observe in Java. So it's not only in JavaScript, we have the same thing in Java. One thread beats hundreds of them. So, but maybe what happens if I have two threads? Let's try it. So first strange things, I was able to really process 50 concurrent requests with one thread, and it was even better in performance than with 200 threads. So right now, once again, I'm doing it with two threads at this moment. Ignore the first result. Just a couple of seconds, and then, okay, sorry. In order to be benchmark how useful, it really have to take time. If something takes only a couple of milliseconds, you are measuring only garbage. And not even garbage collector, just garbage. So this result will be more or less accurate. Not perfect, but we'll see. So here was 482 milliseconds, and on 95 percentile is better. So it's funny. One thread was better than 200, and basically this is a repeatable result. Two threads are better than one. So what's the best Swiss? How many threads should I use? Who knows? Yes, I have 4 real cores, and probably, I won't waste your time, but the measurements shows that basically something like 4 or 5 is the sweet point, gives the best results. Which is not a coincidence, but basically it means that I'm really using CPU. Because, come on, if you have 200 threads, there is no possibility that in fact 200 things happen at a time, because this poor machine has only 4 CPUs. And even worse, if you have more for cores, if you have more threads than cores, bad things happen, and I'm going to explain you that. Okay, so we've seen that. So first thing, what happened with this Spring solution? Basically, it's not a Spring fault, it's a fault of a servlet specifications, a problem. We had a thread pool, so basically, with every request coming, there starts a thread on a server with a classical architecture, but there is a limit. So servers need a limit, otherwise they will be too easy to call denial of service attack. So typical server may have a limit like 100 threads or 200 threads, not more. It means no more than so many concurrent requests with a servlet. What happens if you have, for instance, this 200 and comes 201? They are not lost, they are not rejected, they go into some kind of queue. It means if one moment this thread pool is full and comes next request, it goes to the queue and waits till one of those requests is ended. But what happens in our stupid Fibonacci? Because it's recursive, all of this is full, the next requests go to this queue, but those ones never end because they wait till these recursive calls are finished. So it never happens. We have a deadlock. And you know what is funny? Such deadlocks, even though it's very artificial thing, very stupid things, same kind of deadlocks happen on real productive systems. So just think about it. So that's a real problem. It's not really artificial one. So we've seen that no blocking is great. One thread is in fact very powerful. One thread is more powerful than 200 of them. How cool. So, and you've seen in fact also the basic of Ratpack. So that's the end of presentation. Okay, now I have something more for you. What is non-blocking? Just we'll be going very quickly about this. What is non-blocking architecture? Who knows? What's non-blocking? You just don't block. It means whenever you have to call some external service, database, you have to read a file, you have to call another thing, you should not block the thread that is doing that. How to do that? With some asynchronous calls. So this HTTP client I used was asynchronous. And basically, okay, I am showing here how it works, but we don't have time to really go through that. We will see on the next screen how it behaves. So typical architecture, non-blocking architecture works this way. We have no threads anymore. So there are physical threads, but our processing is not bound to thread. What we have are tasks. Tasks are things to do. So we have some kind of a task queue, and there is an event loop. Event loop typically has some kind of a thread that looks for a task, takes this task from the queue, processes it to the end. And what may happen inside of this task that we have some asynchronous calls to some other things. What does it mean? We do this asynchronous call, and such asynchronous call may possibly give us another task. It means like I am a worker and do my job, and simply whenever I have to call someone, I don't wait till he answers. I say, "Hi Joe, I need this thing from database. Call me when you get the query." I don't wait till he is giving me, till he connects to the database. That's basically the idea. That's efficient way of working, and it works also in Java. That's a non-blocking architecture. So that everybody is using, and now is also working with Java. Why this thing is very efficient? There is the point, this fourth point. This is because effective use of CPU caches. And unfortunately, okay, I can tell you, if there is a thread bound to some request, and you have like 200 of such threads, what typically happens is the thread asked database, the thread asked another database, made some computation, prepared everything in response. He's just happy to send this response to the user, and then scheduler shows, oh, your time is gone. So this almost ready, just about to commit thread, whole work is not done, is not stopped. Okay, it's stopped. It's not wasted. It's stopped. And another thread starts. What this thread on the CPU level sees? Oh, I have nothing in cache of CPU. I have to load everything. So it loads, it loads, it loads. Then this thread asks for data. And almost when everything is ready, scheduler says, oh, no, another thread. This way, we lose a lot of performance power of CPU caches. And if you want to know more, there, for instance, yesterday there was a great talk about CPU caches by Tom Gabel, or there is a blog I recommend you about mechanical sympathy from Martin Thompson. There are a lot of talks about this topic. Okay, so we know why this solution is cool. But in order to work with that, we need asynchronous I/O. And for a couple of years, we have new I/O in Java. We could asynchronously ask network files. We have even databases that work asynchronously, with one exception, JDBC and SQL. Those are not really asynchronous. There is a solution for that. We'll go to this. So it means it's very easy to do asynchronous non-blocking architecture as long as you use some NoSQL database. Not every one of them, but few of them are really asynchronous. But one thing also to remember, it doesn't mean when you go to this asynchronous solution, it doesn't mean automatically you are faster, better, etc. It's not that. You may even be slower. Depends on the problem. But what really happens, you can control it way better. Because with this OS scheduler 200 threads, you basically have no possibility to tune it. In this non-blocking architecture, you can say, OK, I will be using 2 cores for requests, web requests. I will be using 1 core for database, and 1 core maybe for files. And I can change it if I see this component is too slow or other. That's the thing when you can win. OK, but now funny part. Performance sells well. But from my perspective, performance is not the best thing you get out of this architecture. So, because this architecture solves also a lot of problems that we have with the mainstream frameworks. So basically, it's not that non-blocking architecture is so cool. The blocking one, the servlet, is such uncool. And I will show you why. It's because it contains a lot of magic. Who knows what the magic is? OK, I'm a magician, but what is magic in Java? Tell me magic thing in Java. Magic number, OK. Reflection, that's a good point. Who knows something else? Magic. Magic, what? Yeah, it's magic. So magic is all the things that you don't have really in code, but they change how your application works. So it's uncoded code. And that's a couple of things. Runtime reflection. So you have a method. You don't call this method, but this method is called because it's done by reflection. Aspect like interceptor. How cool. So the method returns 5, but there is an interceptor that makes it returning 6. Happy debugging, yeah? And thread local. Thread local is I would say, from the production perspective, it's the thing that's even worse than public static global variable. Because thread local is a static variable, but bound to thread. Again, happy debugging. Somebody puts something in a thread local, 1 minute later, will take something from thread local, try to find this connection. Who has changed it? Who has read it? It's cool. Class loader, class path scanning, that's the thing that make all those servers slow. They have to analyze where your servlets are, where your annotations are, makes them slow. And what's even worse, comes new version of Java, and it never works again because it doesn't understand this bytecode. How cool. Runtime annotations. This is, as I was doing first Java EE system in 2001, this was very bad thing. This was not programming in Java, this was programming with XML. Who remembers programming with XML? So a couple of you, really. That was a hell. And then we are happy because came Java 5 with annotations. How cool. All this XML went to annotation. It took me a couple of years to find out it's the only thing that really has changed is the file ending suffix. So right now, my XML is in Java, but it's the same, okay, I won't call it badly, but the same problem. So because you have something that's not real code as a configuration, and there's a magic container that interprets it, and maybe it has bugs, maybe it has bad mood, you slept not very well, and you are dependent on that. You can't test. How do you test annotation? Write a unit test that tests if you have a transaction. It's doable, but it's horrible. So generally, all these things are magic, and the magic typically ends on production with that, because and one day, on Friday, when you are thinking about going home, you have null pointer exception because at this day, your server didn't want to inject this bin anymore, just was in a bad mood. So there is even a conclusion. If you work with Java EE and use a lot of auto-wire, inject, or EJB annotations, you may save yourself time and do this very fast solution. That's typically what those systems at the end of the day do. Just throw a lot of exceptions, null pointer 1. Okay, but for many years there was no alternative to that, till the moment we get Java 8. And we can now, right now, code as a normal human beings with something called high-order functions. So I don't have time to explain you that, but basically all the things that you have in annotation, transactions, security, basically almost all of them, you can replace with a simple concept called high-order function, and all of design patterns, the behavioral ones, you can replace with this concept. And there is a great talk from Mario Fusco, GOF patterns, on that. So go to there and check. If you want to hear me bashing annotations with details, there is my talk on annotations. I will be giving it this year. There is a video. And there is a great page that gathers all the annotation maniacs as me, that you can share things. I recommend you to go there. But OK, that was second part about we can program normally with functions, right now with Ratpack. And can you do something bigger with that? That's a typical question. So in order to prove that, I published the GitHub project, this one, which does a Pong check. What is a Pong check? Pong check is my exercise I'm doing with typically every framework. Web framework or GUI framework. What does it say? Somebody comes to me and says, I have perfect web framework, JSF. And my question is, can you do Pong with that? Because in 1973, Pong was done first time on CPU. It was previously on analog machine, but on CPU. And my answer is, because I typically hear, oh, no, it's not for games because it's only for forms. And I say, sorry, man. The people were able to do Pong in 1973. If your framework cannot do Pong, it's not ready for year 2017 because it's not even ready for 1973. Forget it. So right now, the Pong check, and maybe you've seen it at the beginning of a talk, and I was playing with Pong. So just only to show you that something is working, I will do it quickly. So that's my Pong server. Oh, that's a Spring one, sorry. I wanted to cheat you and start the Spring version. OK, there is a Pong. Server is started. Just a second, and the real Pong server has started. And I have somewhere here. OK, that's my second thing is here. So it works this way. It's a multiplayer game. Oh. What? Oh, sorry, thanks. Oh, I thought my demo is broken. Where is my server? Here. Cool. Thanks. Da-da-da. Oh, it takes more time this time. You will see why later. Oh, it didn't start. Demo effect, but don't worry. We'll deal with that. I was doing something bad, so I will start it again. Ta-da. This time it should have started. And yeah, what on this server works, I will show you. I can, right here, I can register user with some password, registered. Then second user with some password, registered. And then I can create game like GeeCON. Okay, GeeCON is okay. Then I have a game, then I can play it. And it's the most beautiful version of Pong that you would see in your life. It's this. And I can play this multiplayer. You can play it in a network. Unfortunately, I don't have that much time to go into to show you that. But the code is on a GitHub. Try on your own. So basically, it's playable. It's very slow because I am very bad at. So in order to show something on this game, I have to make ball very slow. But you can even adapt this speed. That's not a problem. OK, the code, what is important. This is my blueprint project that I propose for you if you wonder how to do the real project, the real REST service with Java. And here is on the GitHub description how to do all the typical things without magic. That's very important. From WebSockets, WebSockets persistence, services, etc. Everything is there. And I will just quickly describe a couple of aspects, how it was done. So the Pong check. So, but before that, about Ratpack. Thing for you to know. It's the HTTP server library, so it's only for writing HTTP. It's based on netty, which means it's proven, battle-proven. By the way, Ratpack itself is battle-proven. It already has a couple of year history, but it's built on very popular and widely used netty, which is incredibly performant. That's the goal of this project. Uses really Java 8 in an API. You've seen that. And uses no magic by itself. That's a great thing. So how you define, for instance, the games? Here is my API, RESTful API, that under a prefix name, for instance, if somebody does a post with ID, it means he wants to join the game. Then maybe he doesn't give ID of the game. Then maybe he wants to list the game with this get, or he wants to create a new game. Or he's already playing a game and wants to move his paddle. For that, there is this prefix player, so it's player something that you move the paddle. It's like with post operation. So we have get, post. Basically, all of HTTP is provided. And you do it this way. So not with annotation, but with functions. How cool. So this code, you will see later why it's better. But how you render the things, that's typical content of a service. Like, for instance, user repository. So I'm adding user. So I get from the path the ID of user, then I parse some JSON, providing a class that describes the JSON, so new user class. I will show you how it works, how it looks like. Just a moment. Yeah, this. So Fibonacci server all the time. This one. So new user. It's very simple. This class has final field password and basically this. And because of this annotation, I can easily convert it from JSON and to JSON. You can have more complicated classes like game state. It describes the whole game and has all operation. And again, you have public fields that will be serialized to JSON easily or parsed. That's not a problem. Ratpack, in fact, Jackson does it without any problems. The funny thing here is that because I'm using some kind of a repository, I'm not really directly playing. I'm playing with a repository, but I'm not getting the results. So, for instance, registration status, I'm getting the promise, completion stage. And I'll later tell you why it's completion stage. But it's completion stage of add user. So it means my repository will add user, but later, and will give me this, it gives me this promise of that. OK. So with a JSON, we've seen that. So one cool thing is this is playable game. And basically, it's almost fully written immutable. So if you look at the code of this game state, it's how I store the game. It is all immutable. No setters. How, for instance, I do, what happens when the ball moves? I have this operation, push. It means just give me the version of this game in the next milliseconds of time. It means simply this operation creates new game state and returns it. So I'm never mutating anything. This is very cool because it completely, OK, maybe not completely, but it greatly makes easier to how you reason about code. The less things are moving. It's all immutable. In order to achieve that, also I'm using something called VAVR, so previously called JavaSlang, so immutable collection, because the Java util are mutable. Almost all my variables are final variables. I use a lot of monads. Who knows the monads? OK, a couple of you. So I don't have time to, to describe you monads. But it's basically the trick how you work with side effects, pretending that you do everything without side effects. That's a cool trick, but it works, and it makes your code really better, more stable. So if you want to know more, there is a great talk from Mario Fusco about monadic Java that describes those tricks. So basically, at the end of the day, it means you are writing with Java functional code, and it doesn't really look bad. So, composite function. So previously I showed you that Ratpack, you configure Ratpack with functions. It is cool because you can compose them. For instance, here is if I start the server in test mode, in develop mode, or in productive mode, I can compose my parts of configuration. For instance, here is in the unconfigured server method has this lambda x2x. It means server takes configuration as is and returns the same, doesn't change anything. But for instance, the productive version calls some other lambda that changes this to real productive mode. So it's cool. One of the greatest things in Ratpack is how I test. So how you test the HTTP server. So you mock. Good luck with mocking. You surely test everything, especially Mockito. But this is how I test the server. I start the server, really. I call with HTTP client the method, and I parse the response. What can be better? Who thinks it's a stupid solution? Because it's, for instance, slow. So one thing I can show you, but I don't have time, but basically I measured it. For instance, this Fibonacci server starts 3 milliseconds. This server with Ratpack, with Pong, starts because it initializes some database, let's say, starts 16, 20 milliseconds. It means you can do like 50 such tests per second. It's not a problem. It's not slow at all. And this is real test. Funny thing, for instance, security. I told you I don't like annotations. Now there are some frameworks that do security with annotations. Then you write in string, has role, whatever. Good luck, I call it stringly type solution. So the most important things are strings in your annotations. You can do better. And this is how, for instance, I check. I have function list game, and only registered user, logged in user can use it. How it's done? Because this is my function, list games, and this is my high order function that checks if it's securely called. So how it's done, I don't have time, but basically this is the code I wrote with my hands. Right now the security, I know it's working because I can test this code, and there it is. If you are thinking doing security on hand is wrong, I tell you, it's even less code than configuring the same things with XMLs. And you can test it. So, persistence, that's probably the most complicated part, because MongoDB, CouchDB, have asynchronous API, wouldn't be a problem. But most of you have SQL. What to do then? There is a solution I propose called Juke, which is a great and simple project. Say simple, maybe not anymore, but it's simpler for a user as, for instance, JPA, because you're talking to database with SQL. And my experience is that people know what to do with SQL, but once they try to convert this way of thinking to Hibernate, they are just lost. They waste a lot of time. And they are even surprised by how nobody really knows how this thing works. And to avoid these surprises, there's a very powerful tool, Juke, that you talk with Java, the language, almost like with SQL. That's an example. DSL using database connection with H2 database. This code is on a GitHub. Then inside of transaction, by the way, transaction with Lambda. I do, for instance, inserting of scores. This is the code. You see, it's basically almost like SQL. Insert into. How cool. You know when it happens. And in non-blocking architecture, it's very important that you control when it happens. Because, for instance, if it was Hibernate, maybe the field would be lazy loaded. Then maybe you would call this field, and for a moment you would block something. because you don't control it anymore. So in non-blocking architecture, things like Hibernate or JPA are just not usable, in fact, because you can't control the things. And basically, I even say they are not usable in anything. But OK, just look at JOQ. And still, this thing is blocking. What can we do? There is a solution, very simple. If you have something blocking, you can make it almost not blocking with executors. It means I delegate one of the threads, this is my thread, working thread, that will be processing database calls. So whenever I want to call database, in fact, I use this register score, for instance, and I delegate it to the executor. From external point of view, it means I am not blocked. I just gave you a task, and I go a step further. It can return a future, promise, whatever, so you can even wait for the results. But from the perspective of the service, yeah, I don't block, because there is another thread. In order to do that, you have to sacrifice 1 or 2 threads that are doing this job, but they are just taking tasks from the queue and they perform it. That's a trick, and basically such things are built in also in the Ratpack. There is another solution I propose. If you really don't care where your data is, because you only need persistence, there is this thing, I have a talk on that, drop database, very simple solution that works, and you can do it. Also, another great thing, WebSockets. They work perfectly with Ratpack. So I don't have time to go detailedly, but generally today, for most of the things I build, I don't really build RESTful interfaces, because I can do better with WebSockets, because, for instance, my client can react. So if I am doing a game, then, for instance, all these movements, they are done with WebSockets. And if I am even having some business applications, maybe I can show user that your report is just ready with a WebSocket. So that's cool, and they integrate perfectly with RxJava. You see there is RxJava. Cool reactive thing. So the lessons from the Ratpack that I have is like, coding for this is really awesome. Really, I write clean, immutable code. So great. The problem is it's totally different from the things I learned from so many years with Spring or Java EE. The thing is that, for instance, everywhere I see this completion stage, so promises, and C-monadic code. That's the thing you have to learn. It's normal in Scala, not that, or normal even in JavaScript, not that popular in Java. It's great with a JSON integration. It's great in Ratpack. It's great in testing. I showed you that. WebSockets are perfect. Cooperation with JavaSlang, so our project called Vavr right now is cool. And even JVDBC is possible. But the most cool thing is that finally I am immutable. That's great. What is not cool in Ratpack? That's maybe important to know. The problem is Ratpack was created even before Java 7. And at that time, we didn't have completion stage or things like that. They were not standardized. So because of that, we have promises or listenable future or completion stage, basically the same thing under the different names, and sometimes we have to convert. Sorry. The second bad thing is throwing exception everywhere, but that's something we inherit from Groovy. So a lot of these API functions in Ratpack just declare that they throw exception. And monads in Java. Monads are cool, really. Learn this. The problem is writing a lot of them in Java doesn't look good. It works perfect, doesn't look good because Java doesn't have a syntax like that Scala or Haskell or even Kotlin has. So maybe it would be better to write such things with Kotlin. So is Ratpack only such solution? No. So the great solution that is coming in Spring 5 reactive, web functional framework, or RxJava that we've maybe heard, or Lagom. So very quickly about these things. So Spring Functional Web, if you go there, there is a way with new Spring to describe your REST services with functions, as with Ratpack. The bad thing is still the normal Spring is a lot of magic. So my approach and I already asked that, seems that it would work with all of this magic. Without Spring Beans, you can mix, but you don't have to. And my approach, my proposal for you, try to not mix this with the magic. And I would say even looking at this Spring API, it looks better than Ratpack because it's they had more time to think how to do that. So that's the Spring version, Spring 5, functional. RxJava is used for a long time with Scala. If you are not Scala developer, I would say wouldn't be that easy for you. Ratpack is easier. And Lagom. One thing, Lagom is not only REST interfaces, but whole platform. From REST to the persistence with secure REST event sourcing. It's a very interesting project, really well done. I recommend you, if you are working in a big company and want standards, just look at Lagom. It's way more than Ratpack, but it's a well-defined standard and might be a good replacement to Java EE, because they did everything better. But my recommendation, forget about Java EE and Spring. This is really answer from 90s to the problems we have in 90s. Doesn't really work well with the new problems that we have, mobile clients. That's what I think is good and not good. Remember this slide, and that's basically it. Sorry, I have no time for questions right now, but I am ready to answer all your questions after the talk, if you have any on the corridor, or you can mail me, or go to the GitHub and check on your own. It works. Thanks.